Hi everyone, I'm Niels from the Union.ai team, and in this demo I'm going to show you how Flyte 2.0 can help you productionize and scale your AI and ML workloads. So today I'm going to show you how to train an autoencoder with the Lightning framework, which is a popular model training framework built on top of PyTorch. As you can see here, I'm defining a MNIST autoencoder Lightning module. And then we define an MNIST data module. So this is responsible for loading the training data. And down below, I've defined a train model function that will actually instantiate the model from memory and do the actual training. And the final piece here is a grid search function that we're going to train multiple models on over different batch sizes. Okay, so I can run this grid search function locally and it will run and train multiple models. But what if I want to productionize and systematize the process by which I run experiments, and I want to keep track of all the runs that I've done in the past, keep track of all the models that I've trained and store them in actual object store. So to do this, we are going to use Flyte, and this is what Flyte was built for. So the first thing we're going to do is define an image class, image object, and this image class is basically a wrapper around Docker files. You can think of it this way at least. We're going to use this image to define a GPU environment. This GPU environment is the thing that's going to run our training workload. And as you can see here, we're requesting a single L4 GPU. For our grid search task, we don't need GPUs, so we're going to use a lighter weight resource request here of just CPUs. And to use these environments, we are simply going to decorate our functions with the GPU env.task decorator for the training model and the driver task decorator to decorate the grid search function. And that's pretty much it. I can then initialize the Flyte configuration to point to the Flyte cluster that I'm going to use for this demo, and then run the grid search workflow using Flyte run. So let's go ahead and do that. I'm going to use UV run here. Of course, you can use Python as long as all the dependencies are in your virtual environment. And we've got our run URL here. So let's go ahead and visit this. You can see our grid search function has already parallelized our model training tasks. And this will take a few minutes to provision the GPUs for all these tasks. So now we're just going to fast forward a little bit. All right, so as you can see, all 4 training jobs have started. And actually, one of them has already failed. So as the rest of these 3 progress, let's try to understand why. I'm going to go to the debug action button over here. And what this is going to do is this is going to spin up the same exact image and code and create a little VS Code server in this Kubernetes pod that's running this task. So we're going to wait for a few seconds to get this VS Code instance running. And now, just to be clear, this is a VS Code server running inside of my task pod. And we can see all the code that we saw earlier in my local IDE. You can see that I actually put in this intentional runtime error here just to prove the point. So let's get rid of this. So now that I'm happy with my code changes, I can save it. I can actually resume the task. And now this run is just going to progress till the end. While we wait for this to complete, the last thing I'll mention is that Flyte does support fully on-prem deployments. We are actively working with partners who are deploying Flyte on their cloud on-prem. We're also actively working with customers who have similar on-prem deployments. And yeah, with that, Just want to wrap up here by saying Flyte is a Python native orchestration tool that you can basically supercharge your local workflows and run them on a Kubernetes cloud super easily without wrestling with any DSLs. All right, cheers.